have some difficulty on the internet connections, on the stability. Sometimes I know some of you may have problem on the connection of the internet. So no worries, because I will record this session and will upload the recorded session here for your further reference, okay, in the YouTube platform. Okay, so I will give you the link for the YouTube platform so that you can refer from time to time. Okay, okay, but please don't skip this class. Okay, so I am actually request for the students, since I will upload this class session in the YouTube. So, but I would like the request for the students, do not skip the class. Okay, because this class is very crucial, because from here the session, because this is a real time, so you can ask whether what you don't understand and so on. Okay, so I hope you didn't skip the class, because in the previous semesters some of the lecturers comments that some of the students who are actually don't have any problems on the internet, they repeating skipping the class. Okay, they just what I call scan the QR code for the attendance, and then they went somewhere else. So I don't want you to do the same thing, okay, for this semester. And I hope for this semester will be the last semester for the online session. Okay, for the lecturers, actually for this semester, we hope that we can start for the face-to-face class, but due to the some maybe on the universities audit, so we still in the online session. Okay, but please be reminded that for the final exam for this semester, it will be done face-to-face. Okay, so meaning that for the students who are outside from Malaysia, especially for the international students, so I think you need to start the process of applying visa, or maybe applying your renew your passport and so on. So you should come to Malaysia. Okay, because in section 6 I can see that majority of the student in section 6 is international students. Okay, but I don't know where are they, whether they are inside Malaysia or still outside Malaysia. Okay, but if you are outside Malaysia, so I think you can start processing your admission to Malaysia. Okay, so this course information, actually I have already shared in the e-learning platform, and also I have already shared in the WhatsApp group. So maybe for those who just joining us, so okay, I think I will share the course information in the WhatsApp group. Okay, so this is the latest course information with the signature of the director, head of program, Dr. Jasrul. Okay, actually it's the same. So let's go. Okay, I have already shared in the WhatsApp group. So this is the list of lecturers. I am the coordinator for this course. Okay, I can be reached at this is my office and my extension number, but usually we don't use this anymore, the phone number here. So usually the student will contact me through directly through the what I call this one, WhatsApp. Okay, sorry, WhatsApp, and also email. Okay, so we have another one, Dr. Nur Julia for section 1 and section 2, and Associate Professor Technologies IR Dr. Tan Chi Wei for section 3 and 4. Okay, and as you can see, this is the course synopsis. So what will we do for this course is actually, the keyword here is to introduce the students on the fundamental of power electronics. That is the keyword. So actually the power electronics is a big area. Okay, so we will involve a lot of things actually inside this power electronics. We have controls, we have feedback controls, we have circuits and so on. So there are a lot of research in this area. So what will we do is actually to introduce the fundamental of power electronics to the students. So the fundamental is only involved on the use of power semiconductors. Okay, power semiconductors. What you mean by power semiconductors? You have learned this one actually in your electronics one, in your basic electronics. The device, which is the diode, okay, the thyristor or SCR, silicon control rectifier, and the transistors. The transistor is it has a lot of what I call variants, which is the BJT, bipolar junction transistors, and then we have MOSFET transistors, and so on. So we will actually use this power semiconductor device as a switch. Okay, you may recall that in electronics, for example, for the transistors, there are two functions of the transistors. The first one is, what is the function of the transistor? Ahmad Faleh, are you here? There are two main functions for the transistors, electronic transistors. Can you name what is the first function of the transistors that you have already been taught during your electronic class? Okay. Two-way communication is much
amplifying.
Okay. Who's speaking? Oh,
Yuvaran.
okay, Yuvarajan. Okay, thank you. Okay. What is the first one that you want to...
As an amplifier.
Okay, good. As an amplifier circuit. Okay, and then the second one?
As the switch.
Yeah, as a switch. Yes. So some of your friends also say in the chat, right down in the chat room. So amplify, and the second one as a switch. Okay. So in power electronics, okay, so actually in electronics, you are being taught about how to use transistors to amplify signals. Okay, there are various circuit. Okay, but in this power electronics, we don't use transistors or power semiconductors as an amplifier. We don't use that. We use these power semiconductors as a switch, meaning that we use transistor as a switch on and off, on and off. Not manually, but automatically. So we need to design the control circuit so that the transistor is on and the transistor is off. Okay, so we will use this power electronics is actually more on how we can actually operate our power semiconductors as a switch on and off. Okay, and then we will introduce you about the rectifiers, meaning that the AC to DC converters. Okay, and then we have the second circuit. This is actually the main circuit inside the power electronics area. Okay, the second circuit that we will introduce you is actually how to operate these power semiconductors, or how to use these power semiconductors inside a circuit that we can use that for DC to DC conversion. Meaning that from 10 volt to 5 volt, or 10 volt to 20 volt, and so on. Okay, and then lastly is the third converter, which is we call these inverters. Okay, so this is actually the inverter is the circuit that is used to convert DC power input into an AC output power. Okay, so all this we will analyze on their performance, their operation, how they is operated, the analysis of the steady states, and so on. Okay, and then one more thing is actually we will go on some of the applications of these converters to control the DC and AC motor. So when we use these rectifiers, choppers, and inverter to control the speed and the torque of the DC motor and AC motor, so this system we call DC and AC drive system. Okay, so meaning that for the DC motor, we want to control the speed and torque. Okay, and for the AC motor, for example, the induction motor, we have a synchronous motor and so on. So this one, in general, we call AC motor drive. Okay, clear on that? So that is the synopsis of this course. And for your information, for this course, the background for this course, it can be can consider as a second course, toughest after the EMT. Okay, just to let you know. So that's why in our final year project, FYP, no students are willingly to do project in this power electronics. So usually the student that actually inside this power electronic for the final year project, usually the student that has been lelong lah, auction, kan? Okay. But actually, this power electronics area is very interesting area actually, because power electronics is actually a system that enable all the technologies that we have currently. Can you name maybe just a brief what you call introduction about the power electronics? It's actually all equipments that involve on the power conversion, they will have some power electronic circuit there. Can you name the maybe some equipment that is very near to you right now? Boleh tak? Can you name what is the power electronic application? Because power electronic is the keyword is actually the power conversion. Maybe you can chat. Okay, laptop. Okay, laptop. But specifically in the laptop, what is the component inside the laptop that involve in power electronics?
Charger.
Yes, charger. So you already know that the laptop there, inside the laptop is a battery. So that battery use a DC current, DC power to charge, okay? And then you usually charge using socket, wall socket, which is a AC. So you need the conversion, okay? The conversion. So that charger is actually what is actually the rectifier circuit there. The AC to DC circuit, okay? And then your handphones, okay, all that related to the power conversion, that is inside, that is where power electronics is all about. Okay? And then I think the most popular right now, the technology is the electric vehicle or EV. Okay? So electric vehicle, without power electronics, we cannot have electric vehicle. Okay? Because inside that power electron, inside that electric vehicle, how to actually to run the motors and so on is actually based on the battery. The battery is DC and usually the motor is AC motor, so we need some power conversion there. Okay, so actually the EV technology is actually where the main the importance of the power electronic you can see inside the EV technology. Okay. So I hope you can have some what you call a brief idea about the power electronics. Okay, so this one I think we can skip. So this is the weekly schedule. So as you can see, we have I think chapter. I think chapter 1. I think 4 chapters only. Okay, 4 chapters. And if you scroll down, we have only 1, 2, 3. Only 14 weeks, which is 1 week shorter from the normal semester. So usually the normal semester is 15 weeks. Okay, but I don't know, but because I am referring this with the UTM calendar for this semester, so I have calculated and it is actually 1 week shorter. So this is actually just guideline. Okay, so meaning that for chapter 1, the introduction, so we complete this chapter 1 introduction within 2 weeks. Okay, and then week 3 we will go for the next chapters and so on. Okay, and then as you can see, we have a design project. So project 1 and project 2. So this is a group. This is a group project. Okay, so this is a simulation project. So you are using you will using a Matlab software. Okay, Matlab Simulink software. It's not a programming. Okay, Matlab. I think in the introduction in programming language in your first semester, in your first year, I think you have been taught about the programming using Matlab. But actually for Matlab, there is a Matlab what call Matlab Simulink. So that Matlab Simulink is actually where it's like a PSpice where we use a block diagram and then we connect the circuit, the block diagram, and then we simulate it. Okay, so actually it's actually a straightforward, okay, a very simple software and very powerful software compared to PSpice. Okay, so we have 2 design projects. So I think maybe on second week or third week, I will give you the title of the assignment. And then for the group formation, I think I will form the group for you. So I will select the students, okay, for you, because I know some of you may not kenal each other. So I think it's better for the lecturers to actually to arrange the group. Okay. So for your information, also we have one master student here, one master student that joined our class because she actually need this power electronics for the prerequisite for his for her master course. Okay, so only one student master here. Okay, and then you can see here we have test 1. So test 1 is your first test on 30th of April. This one I think Saturday, 9 p.m. To 10:15 p.m. So this one is during fasting month. Okay, so online, and then we have week 7, which is the mid-semester break. Okay, which is usually our week 8 is the semester break, but right now for this semester, week 7 is our semester break. And then after that, after the semester break, we continue on the second chapter, the third chapter, okay, the DC-DC converters. Okay. And then week 11, we will go for the last chapter, which is the inverters, until week 14. Okay, so week 13 is our second test, which is 18th of June, 2022. So I think the same day, I think Saturday. Okay, Saturday. Because we have space student, we have the part-time student in KL. Okay, so that's why we need to synchronize with their time so that we have decided that all the tests should be during weekend, Saturday or Sunday. Okay, and then so I think this one you can maybe read through. Okay, if you are interested. So this is actually the reference. Okay, so we have the textbook. Okay, you can download it. Okay, actually I have the soft copy, but I'm afraid to share with you because previously in the previous semester, not this subject, another subject, I've shared it, but somehow the Google detected this link, and then that link has been invalid, cannot be retrieved. Okay, so I think you can search this in the internet, and then I think there are several links that you can actually download it. Okay. So Daniel W. Hyde, The Introduction to Power Electronics. So this is our textbook. So most of our notes and examples actually come from these books. This is a very good book, okay, which is very suitable for the undergraduates content. Okay, and then another books that you if you are interested to what you call dig more on the powertronics, you are welcome to download these books, which is from Mohan, Underland and Robbins. Okay, so and then from Muhammad Rashid also. So this is actually a very advanced book, usually for the master students and so on. Okay, very advanced this one. But if you are interested in powertronics, you can download this book. Okay. Okay, I think that's all for the course information. I think I have made it clear on how this course will be conducted throughout these 14 weeks. Okay, so please, for the most crucial part is the test one. So make sure that you are available on 30th of April. Okay, you can update to me, okay, if you are not available, because we need to synchronize with other section also. Okay, we don't know whether this is available or not, because our class is today, so we have, maybe you have class on Sunday, another subject on Sunday and Monday, so maybe this date has been booked by by another subject. So I don't know whether you available or not on this date. Okay, please double check with your schedule. Okay, and then inform to me as soon as possible so that we can rearrange the time. So any questions before we move to the first chapter? Usually, I will only start my class on the second meeting, okay, not on the first meeting. But since the weeks have been reduced to 14, so I think it's better for me to start on the first meeting, because we have a lot to cover, especially on the application of the rectifiers to control the motor drive. Okay, so any questions? So if
Yes, doctor.
yeah,
So doctor, like, what is the course like? What does it focus on? Devices mainly, or like power systems, or like what's the
okay.
main focus?
The main focus is on the circuit. Actually, it's quite different. The circuit that you will experience or encountered during this course is quite different from the circuit that you have already been taught, usually for the electronic subjects and so on. Because this circuit involve switching. So we use these transistors, or diodes and so on, as a switch on and off. Okay, and then we also, inside that circuit, we have inductors, we have capacitors, and we have the load. Usually the load we always represent as a resistor. Okay, so you can see that the circuit will be a very complicated circuit. Not very complicated. It's a very simple circuit, but the analysis of the steady state. Okay, so sometimes when the transistor is on, okay, what happened to the circuit? So we need to see what happened to the inductor voltage, the inductor current, what happened to the voltage of the capacitor, and so on. Okay, and then when the switch is open, what is actually changed? So it's like a circuit theory. It looks like a circuit theory. For example, for the first order and second order circuit, it looks like that.
Oh, okay. I was gonna tell you about the RC and RL transient responses. It's similar to
Uh,
that.
Yes, but not on really on that. Okay, not on the transient and so on. So we are more towards on uh steady state. But it's actually like that lah. I can say that it's complicated. The complexity of the circuit analysis is on like that. First order, second order, and so on. Okay.
Okay, doctor.
Okay. So, but it is actually a very interesting area, actually, subjects. For your information, I actually okay. Some background my background is actually I am also a UTM student for the degree program. Okay. And at that time, I completed my degree program in 3 years because we have a special program. So I involved in that special program. So 3 years for the undergraduates program, and then masters also in UTM, and PhD also in UTM. So I actually 100% pure blood of UTM. Okay, so during my degree program, so this course is actually I don't have any idea about this power electronics, so it's quite new for me. Okay, so because at that time this power electronics we don't see any application of it. So at that time I only score B grade for this course. Okay, but and then to continue my master program. So I'm actually more towards on power systems. But I have several friends that uh, what you call pujuk lah they requested me to actually join this power electronics research area. So and then so I tried, and then from that I can see that this power electronics is quite challenging, but at the same time is quite interesting. Okay, so my PhD is on the inverters. My PhD work is on the inverters, where I use a fuzzy logic control to control the output of the inverters. Okay, so that is a brief background. So actually, before I'm entering UTM, I actually from the what I call the MRSM, MRSM Tunggak Fababa, or previously known as a Jasin, MRSM Jasin. Okay, and then enter UTM, special program, 3 years, and then masters and also PhD also in UTM. Okay, so for those who macam nampak power electronics is quite difficult, but I agree with you at this point is look very macam susah, but it is very interesting. Okay. So any question before we
Yes,
proceed
doctor.
with? Yeah.
I would ask how can join the e-learning for undergraduate student?
Okay, Salama. Okay, you are the Salama. So you are the
Salam.
master. You are the master students, right? So actually, for the e-learning, your name is actually not inside the undergraduate program. So that is the problem. That is the main problem. I cannot insert you because I cannot search. I cannot find your name in the database, in the student database.
How
Uh,
can fix it this
so the notes, okay, the notes I have already shared with you, right? All the notes.
Yes.
Yes. Okay.
I got
So
it.
yeah. So no worries on that because the notes you have already have. So and then for the assignments, and also don't worry, I will actually attain to you personally. So the assignments, and then the submission also you can I will group you with the other students for the assignment. So no worries.
Okay, doctor. Thank you.
Okay. So our communication will be through WhatsApp group. 90% of the communication will be in the WhatsApp group. 10% the e-learning purpose is only for the submission of the assignment and also for the notes. I will upload the notes, but for you, I have already give you all the notes, so don't worry on that. Right? Salamat
Okay,
you.
doctor.
Okay. So no worries on the communication. We will actually, I think maybe 90 to 95% will go through the WhatsApp. Okay. For the submission, no worries. So maybe you can ask your group members to submit it. Okay. Okay.
Doctor.
Salama. You are from where?
I am from Libya.
From Libya. Currently, you are in Malaysia?
Yes, Malaysia.
Okay. So you are your degree in electronics, is it? Your degree,
My degree is electrical power
electrical power. But why you need to take this course?
because UTM give me pre-master courses, 3
Oh, I
courses.
see. I see. I see.
Uh,
Maybe because your degree program have
yeah.
the credit is not maybe not suitable, so that's why we need the
Yes.
student to take another extra course. Okay. Okay.
Yes. Thank
Okay.
you.
Thank you very much. Okay. Any questions before we proceed with our first class? Currently, we have 27 for section 5 and 19 for section 6. I cannot see the program, whether you are SEEE or SEEM, but I can see that some of you are from SEEM. Okay, but so maybe mix of this. The program is mixed. The student program is mixed for the section 5 and 6. Okay, so if there is no question, then we can proceed with this our class. So I will share with you the PowerPoint. So I hope you have already downloaded it. Okay. Okay. So welcome to all of you. So this is the first chapters, the introduction to power electronics. So the sorry for this one. This one is actually the previous code. Okay, so it should be SEEE4433, but actually the content is actually same. So let's begin. So what is power electronics? So this is the keyword in power electronics. So which is the first keyword is electronics. So electronics, so the solid state electronic device and their driving circuit. So this meaning that is actually referring to the electronic device that we will use in power electronics, which is we have the diode, we have the SCR, and then we have transistors. So this is the three device that we will use for power electronics circuit. Okay. And then the second keyword is power. So power is actually the static dynamic requirement for generations, conversion, and the transmission of power. And then the third keyword is the control. So power electronics is also involved about control. Okay, so the steady state control, the dynamic stability of the closed loop systems. Okay, so this is the three keywords that related to the power electronics. Okay, but for your course SEE4433, we only concentrate on the first and second keyword. We will introduce you about the circuit. Okay, we will not go for how to design the control for the power electronic circuit. We will not go here. Okay, so we will only concentrate to introduce how to use the diodes, how to use the SCR, the transistors on this circuit. Okay, so the definition about power electronics is, you can see here, is actually the application of the device, the electronic device, which is the diode, the SCR, and the transistor, to control and to convert the power. Okay, so this is actually the application. This is actually the general definition of power electronics. So what is power electronics? It's actually the use of application of the devices, electronic devices, transistors, and so on, to control and the conversion of the power. So for example, we have AC to DC conversion, we have a DC to DC power conversion, and we have DC to AC power conversions. Okay, so and then the second definition is actually more general, is actually to convert and to process and to control the flow of electrical power by supplying a voltage and current in a form that is optimally suited for the user loads. Okay, so this is, for example, you have AC power plug, you have earth, you have live, and you have neutral. So this is 240 volt RMS. Okay, so how can you use this to actually battery? Battery use 12 volt. So you need an AC to DC converters. So this is actually the power electronics. Okay, you process and you control the flow of electrical power, because right now the flow can be from here, from the plug, from the input to the battery. It can also flow from the battery to the power supply. So you need to control the power flow, whether it is from input to the load or from the load to the input. Okay, and supplying voltage and current in a form that suit for the user load. For example, right now 12 volts. It requires 12 volt battery voltage. So you need to convert the 240 volt RMS AC into a 12 volt DC voltage. So that is what it means by this definition. Okay. So this is actually a simplified block diagram of the power electronic circuit. So for example, this one is your AC 240 volt RMS, and then you have this circuit, okay, and then you have the load. For example, your load is a battery 12 volt, and then another extra is what we call the feedback control circuit. For example, maybe this one 13 volts, but the load requires 12 volts. So you need to have a feedback so that it gives information about the information, and then to the circuit, so that the circuit will actually adjust the output to meet 12 volts. Okay, that is the function of the feedback control circuit. I think you have already learned about how to control, how to design control feedback. Okay, for example, the PI, PID, and so on. Okay, the location of the
Doctor,
pole. Sorry.
sorry, Doctor. Doctor, the majority of us are taking control systems this semester. So
Oh, I see. So
yeah,
you don't have any background on the control yet.
no, we have a background in system modeling, so we understand the control feed and the feedback, but not in so much details.
Okay,
So
okay.
maybe
Okay,
while you're
okay.
explaining, maybe you can give us more details so we can understand the full picture.
Okay, okay. Never mind, never mind. Because as mentioned before, we will not go here. Okay, we will not go here. So just to give you a big picture about the overall system, the power electronics system. So we need to have a feedbacks and so on, and then we design this one, the PI or PID and so on. So and then so that the power electronic circuit will adjust the output to meet the load. Okay, so that is the purpose of general control structure. Okay. So this is the simplified power electronic systems, and this is more detail about the power electronic system. So this is actually the main power electronics circuit, which is the, for example, this one is AC input, and then this one is, and then your load is DC 12 volt. So we have AC to DC. So this is our main circuit here. Before that, so meaning that we have some filter circuit, and then this one also a filter circuit. So filter meaning that, for example, maybe our AC voltage has some distortion. It's not a pure sinusoidal. So this filter will filter out all this disturbance here, this distortion, so that the input to our circuit is a pure sinusoidal. Okay, a pure sinusoidal. This is the function of the filter. And then maybe the output here is not pure DC. So meaning that it may have some ripple here. Okay. So and then so before we feed to the DC load, so we have a filter circuit so that it filter out the ripple. So the output is a pure DC voltage. Okay. This is the what I call the complete block diagram of the power electronic circuit. Okay. So, but no worries because we will not go here. This filter and so on, we will not go here. We will go on the fundamental of the circuit, the main block here. Okay. This also, the control circuit also, we will not go here. So we only concentrate, just mentioned before, to introduce you about the power electronic circuit. Okay, so for the power electronic circuit, we have we divided it into two applications: the statics, which involve non-rotating or moving mechanical. This one is actually you can go to the lab. So right now, I think week 5. Okay, week 1, 2, 3, and 4 we are still online lab, but starting week 5. You can go to the lab so you can see the DC power supply. Okay, so the DC power supply, so in the lab, okay, so this is actually the application of power electronics, DC power supplies, and then you have also UPS, uninterruptible power supply. UPS is not a courier, okay, it's a uninterruptible power supply. So don't be confused with another courier company. We have UPS also named like that, but that one is a courier company. Okay, yang hantar barang. Okay, this one UPS is uninterruptible power supply. Where you can see this UPS. Most of the students, the previous students lah, they don't know what is UPS. Where you can see this UPS? UPS, uninterruptible power supply. What is it actually? Hospital. Yeah, hospital. Okay.
Generators, you mean, doctor? The hospital.
Generator. Yes, but generator. Okay, generator and UPS is different. Generator is actually use diesel or petrol, right, to generate electrical power, right? It use diesel, okay, to generate electricity. But UPS is different. UPS is not a generator. It's actually the source of energy come from the battery.
So I still don't understand how hospitals can be.
Okay, so that hospital is very big.
UPS.
It's very big. You can see the suitable example is the server room, or maybe your computer. Your computer. So actually the desktop. Okay, the desktop one, not a laptop, a desktop. So your computer CPU directly get the power from the AC supply, right? But suddenly, if the power outage, okay, blackout, so your computer will also turn off, right? Because it directly supply from the AC power plug. Okay, so how to avoid, for example, if you are actually typing something important and then maybe you are in the middle of gaming with your friend, okay, and then last stage or maybe the highest level in your gaming, Roblox and so on. Okay, so suddenly there is a power shortage, blackout. So you may have been some frustrating there. So how to avoid that? How to avoid that your computer is off during the power shortage? You need to have some power backup, right? So you need to actually buy extra item or extra device, which is what you call UPS. It's actually a box, a very big box, a rectangular form. Okay, So actually, this wire, okay, from your AC plug. So inside here, we have a battery. Okay, so this is AC. Okay, so this is a DC battery. So we have the converter here, which is the inverter. Sorry, rectifier. So it will charge the battery. It will charge the battery. Okay, and then this is plug. Okay, so you have, so from the battery, it will supply the AC plug, and then this AC plug is go to your computer. When suddenly there's a shortage, this blackout, your computer will still turn on because you have the power come from the battery. So this is what you call UPS, uninterruptible power supply, meaning that if there is a power shortage, power blackout, your device is still working. Okay? I hope you understand. So we have battery here. So the energy comes from the battery because during the normal operation where we have the AC power supply here. So usually the AC power supply, we charge the battery and then we also supply the computer. But when we have a power shortage or blackout, which is where we have a no more AC source, the computer will be continue to turn on because we have the battery. The battery will supply the power to the computer. But usually that one will have maybe depend on the capacity of the battery. So you can have your computer turn on maybe 1 to 2 hours only. Okay, depends on the capacity of the battery. That is what we call UPS. The hospital is a very big is a very big example there. But yes, hospital we have sometimes we have a standby generator, okay, and then sometimes at some part we have UPS, okay, because we have, hospital, we cannot have the power blackout in the hospital because there are a lot of critical equipments. For example, the oxygen generate, the oxygen supply. We have computers and so on, and then sometimes during the operation and so on. So we don't want to have a power shortage there. So when sometimes when there is a power blackout, so the hospital will be actually supplied by this UPS system. Okay. But usually the hospital will not use UPS lah. I think for the hospital they will use a generator because generator will supply actually have a larger capacity. Okay. I think the most suitable example to say about this UPS is the computer lah. Okay. For example, this one computer, and then for the server room, the room that have a server there, because the server, if the power blackout on the server, so all cannot go for the internet, right? So we need to ensure that the server has continuous power supply. Okay. And then another one is about HVDC, high voltage DC transmission. We have, so what is HVDC actually all about? Can someone give some opinion?
High voltage DC, doctor.
Yeah.
Isn't like the electricity transmission from one country to another.
Yeah, good. Why we need the HVDC from one country to another country?
Because sometimes they don't use the same frequency, hertz. So
Yes.
that's
Yes.
one of the reasons.
Yes, good. Because for example, this is a Malaysia. Okay. We have Thailand. And then this is a Malaysia. So Malaysia use 50 hertz frequency. Thailand, what is the frequency for the power system?
50, right?
Huh? Thailand?
50?
No?
60?
Yes.
It's one of the two.
60 hertz. So Thailand use 60 hertz, but Malaysia 50 hertz. Okay.
Okay.
Okay. For example, maybe for the power market, sell and buy. So maybe Thailand have what called extra power generation. They want to sell it to Malaysia. Okay. So but we cannot sell it. Okay, unless it is converted into 50 hertz. So how to convert? Because Thailand is 60 hertz. So Malaysia is 50 hertz. So you cannot directly sell like that. So what you need to do is actually we have installed a okay, so this line and this line. So this is AC. This is AC 50 hertz. Sorry, this is 60 hertz. This is AC 50 hertz. Okay, so to match this AC power line, so we have this HVDC. So we convert AC to DC first. So from AC 60 hertz, it convert into a DC voltage. And then transfer to Malaysia. Okay. We have one power transmission HVDC at the Gurun, Kedah. Okay. And then convert back to AC 50 hertz. So that is the purpose of HVDC. So Malaysia, Thailand is okay. So Malaysia has, I think, okay lah. But you know that for Japan, they are very much more complicated. For Japan, we know that Japan, you have plenty of island, right? For Japan. So actually, for Japan, it's quite unique because each part of their country, even though they are in the same country, some of the part of the country use 50 hertz. Some part use 60 hertz. Some part use 50 hertz. So it's quite complicated. So they have a lot of HVDC here to interconnect their power system grid. Okay, Japan is quite unique because they have multiple frequency for each area. So that is the static application of the power electronics. The second one is the drive application. It is mostly involved on the rotation, okay, the speed, the torque, and the position of the system. So this is much more on the electric vehicles. Okay, majority of them can be seen in the electric vehicles. And we have also air conditioning systems. Okay, we have inverter Aircon, right? Inverter Aircon and so on. So, tapi itulah. Do you know what is inverter Aircon? What is the difference between the conventional Aircon and inverter Aircon? They say that inverter Aircon 50% less electrical bills compared to the conventional Aircon. How can they get 50% less energy usage? That is some of the interesting questions. Okay, so actually in the Aircon system, the most critical part that actually in the system is the compressor. Okay, everything that use air conditioning system. Okay, for example, we have the peti ais, the fridge. They also use compressor because it need to compress the air, the hot air, and then give inside the fridge a cold air. So you need a compressor. So that compressor is actually a motor, rotating motor, to compress the air. Okay, so the power electronics will actually control the motor in efficient way so that the use of the electrical bills is 50%. Okay, so compressor is actually a motor used to compress the air. And this system is actually inside your air conditioning, your fridge, and so on. So that's why I say that power electronics is a very interesting area. It is a very big area, and we cannot avoid power electronics because power electronics is the technology that enables the other technology to be used by the human. Okay, for example, because it involves the conversion of the power from AC to DC, from DC to AC, and then the most I think critical part is on the renewable energy, because we know that for solar, it generate DC power. Okay, but most of our power systems is actually AC system, AC power. So how to match DC power from the solar to be fed to the AC grid? So that is where the inverters, the power electronics conversion there. Okay, so without power electronics, we cannot use the renewable energies for our power supply. Okay, so this is some pictures or some list of the application of power electronics you can see. Okay, so for example, induction heating. Induction heating kan. So kalau yang perempuan, for the girls who always help their mother during the PKP, the MCO motion where we cannot go outside. So most of us actually make the food by themselves. So maybe we have in the kitchen, we have induction heating. We don't use gas anymore. So induction heating is actually one of the application of the power electronics. Okay, we have weldings, we have lighting and so on. Okay, and then the transportation, we have electric vehicles and so on. We have the speed train here. Okay, so actually all this one is actually come from the power electronics. And then we have what else? We have the HVDC, we have the wind turbine. So wind turbine is a renewable energy where we convert the wind speed into usable electrical power. And then we have the solar. And then what else? Okay, and then power supply for our equipments. For example, the computers also, because we know that inside this computer, the motherboard use a DC power supply, but the power supply is still AC, so we need a voltage regulator there and so on. Okay. And then home appliance, lighting, heating, air conditioning. We have what call this one? Washing machine. It's actually all power electronics are actually within our ni lah sekeliling lah Okay, and then satellite, rockets, and then so this is the installation of the. So actually, this one is actually from I think from Australia. So where we have what we have a very unique application, BIPV, building integrated photovoltaic, where the roof is installed with the solar panels. Okay. And then, okay, this is an electric vehicle. So this is, I think, the Mitsubishi MIEV, I think. Mitsubishi, the first Mitsubishi electric vehicles. Okay. So as you can see here, we have the lithium ion battery. This is a DC battery. And then this is actually an AC motor. Okay. So the battery supply is not supplied directly to the motor. It's actually supplied through the inverter here. Okay. And then go back to the motor. Because the inverter, we actually convert DC to AC. Okay. And then, so this is also a configuration of the electric vehicles. So for your information, the electric vehicle, we don't use gearbox. Okay. So we don't use gearbox. So the motor is directly coupled to the tire. Okay. So there is no gearbox. Unlike for the conventional car, we use a gearbox, right? But for the electric vehicles, that is the advantage of electric vehicles where we don't have gearbox. And then this is one more this is actually another configuration about the electric vehicle. We have the hybrid, we have the pure EV, and so on. So actually, the pure EV here, the new research area, for example, this one, the previous research where is actually the motor is coupled to the tire, and then another, the rear tire is actually coupled from using a drive shaft and so on. But for the future, because this one we have losses on the mechanical losses here, so we want to avoid the mechanical losses. So what we do is actually we install the motor directly inside a tire. So no more rim, no more sport rim. So all actually installed inside the tire. So meaning that we have 4 motors directly inside your tire. Okay, this one will actually give more power because we don't have any losses. Okay, because the power from the motor is directly to the tire. No more drive shaft, no more coupling and so on, mechanical coupling and so on, because we know mechanical have a lot of losses. We want to avoid that. And this is renewable energy applications. But in Malaysia, we don't have this wind turbine because it's not suitable for Malaysia. Because I think to generate electricity, the minimum requirement for this for the wind turbine to generate electricity is actually 13 meter per second. Okay, so in Malaysia, we don't have this kind of wind speed. It's lower than that, so it's not very suitable in Malaysia. If you went to or go to the island, Perhentian Island, you will see that there is a one big wind tower installed at the top of a mountain there at the island, and actually you can see that there is no rotation at all because the wind is not very high enough, okay, in Malaysia. So that's why it's not very good. Okay, we cannot install wind turbine or wind energy in Malaysia. Okay, this one, and then there are also new area because currently we want to actually have a more green energy sources. So as you can see here, this is actually a tidal. Okay, tidal. So actually we can see the wind turbine here is actually at the bottom part. Okay, so this is tidal, pasang surut. In Malaysia, I call a pasang surut. Pasang surut. We know that pasang surut. So actually there's a current here, the wave current here. So when the wave current. So we extract the energy from this tidal phenomena in Malaysia. So it will generate electricity. Okay, so actually under the sea, this tidal energy extractor. And then this one is actually, as you can see, this one, ombak dalam bahasa Inggeris apa? Ombak.
Waves.
Wave energy. So this is actually at the surface of the sea. Okay, so we have a wave energy extractor here. So actually this extractor, so inside here we have the power electronics. So the power electronics is actually used to convert the power, the extracted power from this renewable energy into a usable AC or DC power. Okay? Okay. This is renewable energy. Okay, and then another home appliance. For example, we have microwave here. So inside this microwave, so anything that involve power conversion, there will be a power electronic circuit here. So in the microwave, and then DVD player here. So we have the DVD, and then this is the socket, which is AC, 240 volt, but the DVD player only use 5 volt only, 5 volt DC power. So you need, this is actually the circuit that do the conversion from 240 AC into a 5 volt. So this is the circuit to convert this power. and then it will use this 5 volt and then supply to the motherboard. Okay. So anything that use power conversion, so there will be a power electronics. Okay. So the growth in power electronics, so actually as I have already explained to you. So we have power electronics, okay, interest growing inside the community because we need, because of the loads. The loads requires, for example, we have the motor drive, UPS, and so on. And at the same time, also, we need the equipment to be very, very small. Okay, so the use of power electronics, we can make that equipment very, very small and very lightweight. Okay. So, okay. So before that, I think we take a break first, 5 minutes. Okay, for 5 minutes break. Okay, thank you very much. Can we start?
Boleh lah.
Okay. Okay, so just to recap again, so the growth in power electronics, so as you can see, is actually due to the demand of the loads lah. Okay, we requires that we have the motor drive and we have the electric vehicles, and then we need the power to be always on, the no disruption. So we have that, we have the UPS and so on. So this is actually due to the demand, okay, of the power usage. And also there we are increasing demand of the small size and lighter weight power electronic system. For example, the charger, you have right now, you can see that all the chargers, for example, the handphone chargers is very lightweight and very small. It's getting very small and small and smaller. If you compare to 10 years back, the charger for the handphone is very bulky and very big. Okay, but right now it's a very small and very lightweight, and you maybe don't, you cannot imagine what is the electrical circuit inside that. Very, very lightweight. Macam plastik, macam kosong kan. It's very like empty things inside that. But actually that one is actually a power electronic circuit. We make the circuit to become very, very compact and very, very small, and at the same time very efficient. Okay. Maybe you heard about the GAN charger. Have you heard about GAN charger? GAN. GAN charger is actually a very fast charger. Murtaba, why you give thumbs down?
Never heard of it, doctor. That's why.
Okay, so GAN charger is a fast charger. It can be considered a fast charger because it has a very large current, okay, going through the battery. So actually the GAN charger is actually a modern, or what I call a new technology inside the power electronics. So we use very special transistors. So actually this GAN is actually referring to the material used to fabricate the transistor. So we have what I call the gallium nitride, or GAN. Okay, there's a gallium nitride is actually the material used for that particular transistors. So that transistors is a very small transistors, but at the same time has a capacity of to actually operate in high voltage and high current. Okay, so meaning that you can have a very high current flowing inside that circuit, but the circuit is very, very small. Okay. Okay, and then since actually because we use this powertronic circuit is actually a switching circuit. We use the transistor as a switch on and off, on and off. But the switching frequency is not 50 hertz. It's a very high frequency. It's up to 1 kilohertz and higher than that. So when you have a very high frequency, so it will generate what we call electromagnetic interference, or EMI. So even though the power electronic circuit is good, but there is some bad thing or the drawback of the power electronics circuit, because it will generate this unnecessary disturbance to the circuits, okay, which is the EMI. So disturbance is actually just like a noise lah, okay. So but this EMI is actually can be filtered out, okay. It can be filtered out using a inductor, just a very small inductor. You can filter this EMI. Okay, so the objective of power electronic circuit, as can be seen here, is to match the voltage and the current requirement of the load to those of the source. Okay, so this one you have source, and then this is the load. So this converter will actually convert the current and the voltage so that it will suit the requirement of the load. So very simple objective for the power electronic circuit. Okay, so the changes in current and voltage can be in the VI form, which is to the conversion of the AC to the DC. Okay, and then the conversion in terms of the magnitude. So maybe the voltage 20 volt boost to 50 volt, or maybe 10 volt reduce to 5 volt. So this is actually in terms of the magnitude. And then the conversion also can be in terms of from single phase converted into a three-phase system. Yes, the power electronic can do that. Okay. And then the conversion also in terms of the frequency. Okay, from 60 to 50 or from 50 to 60 hertz. So the conversion can be either in terms of frequency. And the last one is in terms of the shape, whether it is sinusoidal, non-sinusoidal, triangular, and so on. Okay, so this is actually the change of the power conversion that can be done by the power electronic circuit. Okay, so this is the conversion classifications. So if the AC input, the DC output, the conversion type is called rectifications. And the circuit name is the rectifier. And then the second one, if the input is DC, the output is AC. This type of conversion is called inversion. And the circuit that referring to this type of conversion is inverter. And then if you have AC to AC, so this one we call Cyclo Conversion. And the circuit that use this conversion is what we call the Cyclo Converter. And then we have a DC to DC converter. So this one, the type of conversion is we call conversion. Okay, and then the name of the circuit is a DC to DC converter, or sometimes we call also a DC regulator.
Doctor?
Yeah.
What does it mean, like, when we convert from AC to AC?
Yes, good questions. So AC to AC, you have learned about transformer, right?
Yeah.
For example, 100 volt to 200 volt. So either just a step up or step down. It's like a transformer.
Okay.
Yeah, it's like a transformer. But the transformer is a very what I call high losses, because it use magnetic. The link is actually magnetic. And then so we know that this magnetic circuit has very high losses. and the transformer size is very big and bulky. Okay, but by using this power electronics AC to AC, which is we call Cyclo Converter, okay, it will have the same function of the transformer but very high efficiency. Okay, so actually we can have a 90 to 98% efficiency. For the transformer is around 70% efficiency. So meaning that the power input and the power output, so we have 30% losses from the input. But if you are using Cyclo Converter, you can have the efficiency is around 90 to 98%. Because right now we are concerning on the we are concerning on the energy efficiency, right? Because the bills is quite high. Okay, the price, the tariff is quite high. So we want to make that the load, okay, low losses. Okay, our system is very efficient because because we pay all the things. Because this one we pay, even though 70%, so we pay 100% price actually, because we need to pay also for the losses. Okay, but we don't use that loss. That is the main thing lah kat situ. Okay, but the advantage of Cyclo Converter here is actually beside of it can convert the magnitude 100 volt to 200 volt, it can also use to convert the frequency. So that's why sometimes that's why it's called Cyclo Converter, because it can change the frequency from 50 to 60 or vice versa. Okay, so that is the advantage of Cyclo Converter in terms of the magnitude, and also it can also convert the frequency. Okay. Okay, the power flow. So you have the input here and the output. So depends on the circuit here, the power electronic circuit. So it can be unidirectional. The first one, unidirectional, meaning that the power flow is unidirection, only one flow, whether it is flow from source to the load. Okay, or so from source to the load, meaning that your power flow is positive. Okay, so your voltage, so for example, this one may be voltage, this one current. So this one current positive, voltage is positive, meaning that the power is actually come from the source to the load. Okay, or the voltage and current is negative, meaning that the load is supply the energy back to the source. So unidirectional. Okay, it depends on the circuit here. So maybe the circuit can only supply positive power. There's also a circuit that maybe can supply negative power. Okay, there are also circuit of power electronics that is able to be operated bidirectional, meaning that it can be power positive and it also can have power negative in one circuit. So that's why we have all area here. Whether the voltage is positive, current positive, or we have voltage negative, current positive. Okay, this one V positive, current negative, and so on. Okay, so bidirectional, meaning that the power can be from source to the load or from the load to the source. So it actually depends on the circuit. Okay, I think that's all from me on the introduction. Any question? So yeah.
Just to confirm, for unidirectional, is it only for load to the source?
Okay, for the unidirectional, no, unidirectional can be source to the load.
Sorry, source to load, yes.
Yeah. source to the load or from load to the source. Okay, this is unidirectional. It can only provide the power flow whether it is positive or negative. But for the bidirectional, meaning that one circuit can both, meaning that the power flow can be from both direction.
Okay, Doctor. Thank you.
Okay. Okay. Thank you for the question.
What's the type of electricity used in unidirectional and bidirectional? Is it the AC?
It can be AC, it can be DC.
Interesting. Okay, thank you, Doctor.
Yeah. Because the power can be DC power or AC power. So it's actually there's no difference. You can pause DC or AC.
Because it's returning to the source, so that's where I'm confused in the bidirectional. That's where it's, I think, confused us.
Okay, because right now here, this circuit, inside the circuit, they contains inductors, capacitors, and also a switch. So this circuit, the working principle of the circuit has some DC and some AC. So
I see.
okay.
Okay. I think the further we go with the course, I think we
Yeah,
will
yeah.
understand this
Yes.
this example. Thank
Yeah.
you, Doctor, so much for this class.
Okay.
Doctor, I have a question if you don't mind.
Okay.
Yeah, like you mentioned earlier on that we're going to tend to use Matlab for our assignments and such ways.
Yes, Matlab.
Yeah, like why is it better to use Matlab in comparison to PSpice or Multisim applications?
Okay. Thank you. Very good question. We have three actually suitable suitable software. We have Matlab Simulink. We have second one is a PSpice and sometimes LTC. Okay, and then the third one is a Multisim. Okay, PSpice is circuit oriented. The same thing goes to the Multisim. Okay, so circuit oriented meaning that you need to have a proper part numbers. For example, the chip. Okay, usually usually the problem with this power electronics, if you want to use PSpice and Multisim, is a very circuit oriented, because this one we use a gate driver. After this, I will introduce about the gate driver. So the gate driver is a complicated circuit design. Okay, if you want to use PSpice, so you need to design the circuit driver, a very complicated, because it use several integrated IC. Okay, and that part of IC you need to search inside the PSpice library. So it's quite complicated to design the gate driver, because you need to have a actual circuit there. Okay, actual circuit model for the PSpice and Multisim. But for the Matlab, it's more towards on the system levels. Okay, just for the Matlab, so you don't need to care about the gate driver circuits and so on. So just it's very straightforward and very simple approach in designing the power electronic circuit compared to PSpice and Multisim. I hope you can understand, because PSpice and Multisim is good, but you need to be particular on the part numbers. Okay, the IC you need to, because the gate driver is very complicated design there, because we don't want to involve on the gate driver design. We are only concentrating on to make sure the student understand how the circuit is operated. Okay, in general, in general picture. So for example, when the circuit is on, what happened, and so on. When circuit is off, when the switch is off, what happened. We don't want the student to deal with the gate driver design, because when you want to use PSpice, you need to know how to design the gate driver. That is the problem we want if we want to use PSpice or Multisim. Okay. For the Matlab simulation, I think I will have some maybe training, not a training lah. It's actually just a very short workshop that I will conduct for you, so to get some idea on how to use Matlab for this assignment for power electronic circuit. You will see that this Matlab is very powerful and very easy to use compared to the PSpice and Multisim. And in terms of documentations, for example, the graph, the waveform, it's much simpler to in terms of what you call modifying the legends and the cursor and so on compared to the PSpice and Multisim. Okay. Okay, so we meet again next on our class on Thursday. Okay, 1 hour. So that one we'll go for the, we will introduce you, not introduce, maybe recall back the function of the diodes, the function of the thyristor, and also the transistors. Okay. Okay, thank you very much. Okay, Assalamualaikum and have a very good day.
Thank you, Doctor.
Okay.
Okay.
Ciao.
Thank you, Doctor.
Yeah.
Salam.